Today's lesson is 2.5, adding, subtracting properties in proofs. And we're also going to be talking about the reflexive property. So there's three main concepts that you will take from today's lesson by the end of this video. Let's start out with the addition property. If two congruent segments are added to two congruent segments, then the sums are congruent. Well, sums meaning addition. So we're saying two congruent segments are added to two congruent segments. Okay, the proof here is done for us. We just have to give our reasonings for why Mr. Brygiewski, filled this proof in like this. Our given was AB was congruent to AD, AB congruent to AD, BC was congruent to DE, and our goal is to get AC, which is this big piece, and AE congruent. Well, think about it. The two small pieces are congruent. The two medium pieces are congruent. And if you add the small and the medium, you get the big. Add the small and medium, you get the big. So they are congruent. What does the long proof look like? Well, here it is. We started with the congruent pieces. We had to say they were equal. Going from congruent to equal is definition of congruent. Number two. Number two, we're going from here to this statement right here. So basically, what are we doing? We're taking AB, we're adding BC to it, and we're taking AD and adding DE to it. So this is where we're doing addition. 3 says, you see the word between, and then we're going into these statements. So it's definition of betweenness. 4 brackets all three of these together, and basically because this is here, we could say these two are equal by using substitution. And finally, back from equals to congruent, we have definition of congruent. This is the long way to show that two things added together, then their sums are congruent. What you want to do is you want to do it the short way. The short way is right here in this box. So highlight this box for me. You're starting with the two givens. AB is congruent to AD. The other given, you bracket them together with an arrow. You can say go right into the congruent pieces to the other congruent piece being congruent. And the reason for it is addition. All right. You know it's addition because what you are looking for, your end result in the picture, is bigger than your beginning. Okay. You had two smaller pieces. We were getting a bigger piece at the end, so you know it's addition. Moving on to the next major concept. The next major concept is right here, reflexive property. Any segment or angle is congruent to itself. Reflexive property, you remember it like a mirror. It's a reflection. What do you see in a mirror? You see yourself reflected back at you. So reflexive property is when you share the same side in multiple pieces. All right. Example 1 kind of shows this. We have QR congruent to NT to begin with. We want to prove QN congruent to RT. Well, sure, we know that this little piece and this little piece are congruent. And what happens is they both share angle or segment RN. So RN is the reflexive piece. It is being shared between both of them. So you can say that RN is congruent to itself. So what does the reflexive look like? The reflexive looks like you would say the same thing is congruent to itself. You need an arrow in front of it, and this reason would be the reflexive reason. Okay? So let's do this proof. What happens if we have QR and T? You know this is reflexive. Basically, if we add the smaller piece and the reflexive piece, the smaller piece and the reflexive piece, we get the piece we wanted. So what does our proof look like? We got QR congruent to NT. Underline it because it's given. We need to add the reflexive piece to it. So this one, you need an arrow at the beginning. Put a 1 there. or you could say it's from the diagram. Either way, whatever you feel more comfortable. If you feel like putting a D here and underlining it, that's fine. You don't have to, but you can. What do we know? The reflexive piece in this case is Rn is congruent to Rn. And using our new addition property, if we add QR and Rn and NT and Rn, we get our ending result Qn congruent to RT. Reason one here, when something is congruent to itself, it's called reflexive. And two would be the addition we were looking for. Okay, let's move on to example 2. Example 2 says, if two congruent angles are added to two congruent angles, their sums are congruent. So this time, still doing addition because we have the sum here. We're going from segments to angles. I allow you to just say it's addition instead of angle addition or segment addition. So let's see here. Given angle 1 is congruent to angle 3. Prove that angle ABE is congruent to angle DBC. All right. Do either one of these two angles share something? That's right, angle 2. Angle 2 is being shared right here. So if it's something being shared, you call it what? Back up here. If it's being shared between something, it's congruent to itself. So that piece is reflexive. Angle 2 ends up being reflexive. Well, then how do you create ABE? You add angle 1 and 2 together, and then you add 3 and 2 together to get DBC, and you have your proof. So let's start out with angle 1 is congruent to angle 3 given. Arrow out on its own line for a reason. Like I said, if you want it from the diagram, go right ahead. Angle 2 is congruent to itself, so it's congruent to angle 2. These two together using our addition property. Angle ABE is congruent to angle DBC. Reason 1, reflexive. Reason 2, addition. Hopefully both of those are starting to sink in. I recommend adding them to your flashcards that you have. Now we're going to switch gears a little bit, and we're going to go from the addition, and now we're going to be talking about subtraction. If two congruent segments are subtracted from two congruent segments, their differences are congruent. So let's see here in this example. We start with AC, this whole thing, being congruent to EC, and then BC, this piece here, congruent to DC, and our goal is to get AB congruent to ED. Well, think about it. We have the big piece and the small piece. If we subtract the small piece from the big piece, what are we left with? The medium piece. So in this case, if you look at a picture and you are getting a smaller end result like A, B, and ED, then you are using subtraction. So you actually have to look at the picture to see if your end result is bigger or smaller to know if you're using adding or subtraction. Do not just guess which one it is. You will not see adding or subtracting in your proof. So let's do the reasons for the proof the long way. B is between, so we see the word between, so we do for one definition of betweenness. Number 2, congruent to equals, so that's a definition of congruent. 3, we're bracketing these three statements together and stating this. Well, if AC is here, EC is here, both of these added together are okay. So that's just a substitution. 4, we're taking these two statements and we're getting rid of, it looks like, BC and DC. So when we get rid of something, what are we doing? Subtraction, that's correct. And 4, back from equals to congruent, So then that's definition of congruent. This highlighted is the short way of saying something is subtraction, right? So reason one here would be subtraction. Remember, do not use the word sub because you don't want to designate between substitution and subtraction. So AC was congruent to EC, BC was congruent to DC. These were both given from above. You could bracket them together and say the other two are congruent, and what happened, your end result was smaller. Let's look at example 3. If two angles are subtracted from two congruent angles, their differences are congruent. So subtraction, difference. So we're starting with this given ABC. ABC, this big angle here, is congruent to ACB, this big angle here. Angle 1, the smaller angle, and angle 3 are congruent. So that means angle 2 and 4 have to be congruent because they're left over for your end result. All right. So let's see here. What is the proof going to look like? Well, ABC is congruent to angle ACB. Underline it. It's given. Angle 1 is congruent to angle 3. Underline it. It is given. Bracket these two together. I can state angle 2 is congruent to angle 4 in one reason, and that reason was subtraction, because the picture end result 2 and 4 were smaller than the beginning ABC that we wanted. Last example for today. ABE is a right angle. I'm sorry, BAE is a right angle. So here is a right angle. AD is perpendicular to AC. AD is perpendicular to AC. Well, perpendicular causes a right angle, so this is going to get a right angle at angle DAC. DAC. All right. So we got another right angle right here. Well, we want to prove 1 and 3 are congruent. Well, a right angle here and a right angle here. Do those two right angles share anything? That's right. Angle 2 right here. They share this angle. So when you share something in a picture, what reason is it? Reflexive. Good. Well, first off, we need to get that both of these right angles are congruent. Right. That's correct. All right angles are congruent. So we need to have all the right angles congruent, use the reflexive, get rid of the reflexive, and we're left with 1 and 3 left over for our proof. So let's start with making the right angles congruent. So we got ABAE is a right angle. There's the first right angle. The second right angle comes from AD perpendicular to AC. Underline it. Arrow out. Reason 1, angle DAC is a right angle. These are both right angles, so we can bracket them together and say angle BAE is congruent to angle DAC. There's the big angle congruent. We said we wanted to use the reflexive. So on its own line, you could say from the diagram, that's fine. We're up to reason 3. Angle 2 is congruent to angle 2. These two together, using our subtraction, we can say 1 is now congruent to 3. So now you're going to start using the all right angles are congruent idea on your own. Reason 1, all right angles are congruent. Reason 2, I'm sorry, reason 1 was not all right angles are congruent. Get rid of that. Reason 1 was, watch your numbers, right here, which is definition of perpendicular. Reason 2 is all right angles are congruent. Reason 3, we've been using it this whole time, reflexive, because it's the same thing to itself. And 4 is our subtraction. Remember, if in addition, if your end result is bigger in your picture, it's addition. If it's smaller, it's subtraction. And don't forget, a shared piece is the reflexive piece. We will be using that throughout the entire semester, all three of these ideas. Good luck on your homework. Have a great day.